We are discussing let us C programming, and this is chapter number 2, the decision control structure. Use of logical operators. We have 3 logical operators in C, which is AND given by 2 ampersand, and then we have OR, and this is NOT. So AND, OR, NOT, these are 3 logical operators, and what they do we'll just see in a bit. These 2 operators, they allow more than 2 conditions. This can be combined. If you use if you use while, if you use for, all these, in this we can have these ampersand and or, we can have multiple way or conditions that can combine to a single output that is true or false, right? We'll see it with an example. That this is a marks obtained by a student in 5 different subjects. This has to be inputted through the keyboard, and the student gets a division as like this. That is percentage which is above or equal to 60, it has to be given first division, between 50-59 second division, and 40-49 third division, and below 40 it should be fail. So how to write a program to calculate the division which is obtained by the student? So there are different ways. First we'll go ahead with the normal way which we have learned up till now. That is, this is method 1. We are not using the operators here right now, we have discussed. But what we are doing here is, we are taking M1 to M5 the marks. This is percentage. We are inputting the values in %D from M1 to M5. We are adding them, dividing by 5 and allowing it to go to PER. This if PER is greater than or equal to 60, we print first division, else. If PER is greater than or equal to 50, we say second division, else. If PER is greater than 40, we say third division, otherwise we say print fail. So there are multiple if and else's we have used, and this does the job. But this is very straightforward program. We have various if else's here. There are certain disadvantages if we use if else's. More, if you use if else, nested if else, there may be certain things which we have to understand. As the number of conditions go on increasing, the level of indentation also increases. That means the whole program creeps to the right. That means care needs to be exercised to match the corresponding ifs and else. If you lose one brace or one curly bracket, there will be a problem. So you need to care to match the corresponding pair of braces. All these problems can be eliminated if we use the logical operators. Let us see the same program using the logical operators. How? Same thing we have done, taking M1 to M5 and entering these values and finding the PER, that is the percentage, adding the marks and dividing it by 5. Now, if the percentage is greater than 60, we say first division. But now the second one, we know 50 to 59, we have to take a range. What we can do here is, if PER is greater than 50 and PER is less than 60, that means in AND, if both the condition on left and right hand side, if these are true, then only it is going to give you true. So if both are true, then second division. Then we again check for if between 40 and 50, if both these are true, we say third division. And then if pers is less than 40, we say fail. So same thing we have done with ampersand operator, and the 2 distinct advantages we see here. First, we don't have to match so many if and else's, and we have various conditions, but still this program becomes more effective than multiple if else's. Else if clause. Else if clause is what? See, we can write a program to enter the marks of 5 students or 5 subjects of a student, add them, divided them by 5 and find out the percentage. Now this percentage can fall in various categories, first, second, third and fail. How to write that program? We can write the program like this. This is a if ladder demo, and we just take from M1 to M5 and add them all, dividing by this is 5, sorry. This is 5. Now what we get here is percentage. So we add them, divide by the value 5. If there are 5 subjects, then we say it is PER. Now percentage, if it is greater than or equal to 60, we say first division. Then rather than putting if then else, then again if else inside this, again if else inside this. For checking all these conditions, we can use else if. So if this is the condition, we print else if percentage greater than 50, second division, else if percentage greater than equal to 40, third division. So if this condition fails, then it goes to this else. If these both condition fails, then it goes to this. Otherwise, if these condition, all three conditions fail, we're going to fail. So you can note here the indentation is very clear, the formatting is very clear, the last else is optional, but the else if has taken its place, and else if is nothing but we are just combining the if else. So just the code you can see here, it is evident that I equal to 2, you print something, else j equal to 2, print something. Now we can combine these. This is nothing but you are combining this else and if. This else and if you are combining and giving it to else if. So you are just reducing the line and making it more clear. Your program look more clear, formatted and understandable. So if I is equal to 2, you print something. Else if j is equal to 2, this else if you have used instead of this else if. There is another place where this logical operator can be very useful. We want to write programs for complicated logics and we have two answers, true or false. If it boils down to true or false, we can employ the logical operators. For example, we have a question: a company insures its drivers in the following case. Driver is unmarried, driver is married. Then driver is unmarried, male and 30 plus, or the driver is unmarried, female and about 25 plus. So in all of the cases, the driver will not be insured. So the marital status, sex and age has to be inputted through keyboard and write a program to determine whether the driver is to be insured or not. How can we use? See, first this is somewhat complicated situation, but we can easily solve it. First, we'll use without using logical operator, and we'll see how this logical operator, if we use, will make the program quite easy. See, first we'll try to show it without using logical operator. We have a char. This is your sex, this is your marital status, you have age. Just enter the age in %d, that is integer, sex and marital status in character. Now, if the marital status is married, we say that driver is insured. Otherwise, if sex is male, age, then we have to check for the age which is greater than 30. If it is greater than 30, he is male and we say driver is insured. If it is not, he is not greater than 30, driver is not insured. We can have one more condition, else. If these two conditions fails, we go to else if age is greater than 25, driver is insured. Otherwise, driver is not insured because the sex has to be female, right? So if this condition fails, that means the driver is a female. That is why we come here. Now this again have various braces here, various indentation here. Can we solve it? Can we put some logical operators into use so that we can rewrite this program? Let us write this program in other terms, and here let us make certain cases. The cases are like this: that driver is married, driver is unmarried, male above 30 years, driver is unmarried, female above 25 years. So we have three cases in all. Let us use them. We are writing the program using AND and OR operator. So we are taking the char, sex, ms, that is marital status. We are entering the age. Enter age, sex, marital status in these three variables. Now, first condition. See, if the marital status is man, or if any of the left or right condition is true, it is going to show you true. Whole is going to show you true. Any of this, both are true, it is true. One of them is true, then it is true. If both are false, then only OR will give false. How about AND? AND will give you, if both are true, then it will give you true, otherwise false. That is, if one is false, false. If this is true, this is false, false. If both are false, false. So what we are trying to do here is, we are putting first condition here, making an OR. Then the second condition we are placed inside AND. So if these three conditions, any of these is false, it is going to be false. Otherwise, any of these three has to be, all of these has to be true. Then only this will be true. Same is the case after this OR. All these three has to be true to make it true. So we have three conditions, we have the three cases. All these cases we have just put in one line. This one, this one, this one. And if these conditions meet, we say driver is insured, otherwise uninsured. That is how we use the AND and OR operator. So what we have to see here is that the conditions where we have used, the parenthesis we have used, and the parenthesis in AND and OR does this similar trick, that on the left hand side and right hand side on the AND, if any of these is false, it is going to give you false. In OR, any of the left hand side and right hand side is true, it is going to give you true. So what we conclude here is, when it is to be tested whether a value falls within a particular range or not, we use AND and OR. When after testing several conditions, the outcome is only one of the two answers, that is true or false or yes or no, we use AND and OR. So this can be extended to various more operations. Let us take an example, write a program to calculate the salary as per this table. So we have, let us see, we have male. One condition is male greater than equal to 10, postgraduate and 15,000. Postgraduate will take 0 for graduate, 1 for postgraduate. See, all this condition can be combined in AND and OR operation. How? We are taking the character as G. G, if it is 0, then it is graduate, 1 it will be postgraduate. This is year of service, qualification, salary as per the table. So we want the user to enter the gender, year of service and qualification. So we will take these values. If the G, that is this one, graduate or postgraduate, is M, year of service is greater than equal to 10 and qualification equal to 1. So qualification, actually this G, qualification is 0 or 1, that is it has to be 0 or 1 for being into graduate or postgraduate. I hope you got the idea. 15,000 at this stage. This gender G is, if G is taken as the gender, we can just equate it with the male. So gender is male, year of service 10, qualification equal to 1, salary 15,000. How? See, gender male greater than equal to 10, year of service, postgraduate 15,000 salary. This is first condition. Again, all the condition can be met like this. Else if gender male, year of service 10, greater than equal to 10, qualification 0, or because we have 10,000 for both of these. So we can combine these conditions in a OR. First condition or second condition. If any of these is true, we say salary equal to 10,000. Similar is the case with else if, the second one. So gender male, year of service less than 10, qualification 0, salary 7,000. And similarly for all of these. This is how we use the AND and OR operator. Then we have a NOT operator. NOT operator does what? We have seen the logical operation AND and OR. AND and OR, in this AND and OR, we require condition on the left hand side and right hand side and we combine them. This result can be true, this can be false, or any of these. And we combine the true and false to get a single true and false. But not actually inverts. So this is like an inverter. When you pass true, it will give you false. When you pass false, it will give you true. So this negates. Basically, it negates. So this operator reverses the result of the expression it operates on. Just for example, if the expression evaluates to some non-zero value, any non-zero value, when you apply the NOT operator, it will give you 0. So NOT 5 is 0, NOT 555 is also 0, NOT minus 5 is also 0. So the final result after applying this 0 or 1 is considered to be false or true respectively. So we'll take an example first of all, relational expression. Not y less than 10. So y less than 10, if it is y less than 10, not means not y less than 10. What we are trying to say is y is less than 10, the expression will be false since this is true. If this is true, not means it makes it false. So we can express the same condition like this only. Y less than 10 is equivalent to y greater than equal to 10. So this NOT operator is used often where we want to reverse the logical value of the single operation. That is, if not flag. This is another way of just saying if flag equal to 0. If not flag means not equal to 0. So it may seem somewhat confusing. So we usually do it when it is really required. Hierarchy of operator, we have already seen the hierarchy. So the first one is the not. In an expression, if you find not, it will be done first, followed by into, division and modulus. Then we have plus and minus, that is arithmetic, less than, greater than, less than equal to and greater than equal to relational. Then comes the equal and not equal. Then we have and, then or, and then we have assignment. So this is the order of the operators which are going to work when we have, say, an operation, or we have to do operators and operand to find certain value of the expression. There are certain caution you need to understand. First of all, see, this is doing what? This program, can you find some error here? Or what is going to happen? If I equal to 5, you entered 5. Whatever you enter here, whatever value you enter here, it will always give you this line. Why? This is because you are not equating, you are not trying to find out whether I is equal to 5. You are actually assigning the value of 5 to I. So always this I will be 5. Okay, this will be true. So always this line will come. You have to be very careful with this assignment sign and comparison sign. This is what the discussion is right now. One more thing is putting the semicolon. Semicolon means in this particular code, see, you have a semicolon after if I doesn't double equal to 5. Now when you have this double is equal to, that means it is okay. But when you are putting a semicolon after this, that this compiler is understanding that after I equal to double equal to 5, you don't want to do anything. This is a null statement, and you have a null statement. After that, you have a semicolon. So this is done. This line has no relationship with this because you have a semicolon here. So beware where you put a semicolon. Okay, this is just like this. If I equal to 5 and then semicolon afterwards. So therefore, you will always be, you see, when you use for, when you use while, where to put semicolon, where to put colon, this has to be well understood. This summarizes the working of the logical operator. This is x, y, this is not x is 0 becomes 1, y, not y, 0 becomes 1. X and y both are 0 on the side and will always give you 0 when both are 0, or will give you 0 when both are 0. But any of these non-zero, any of this non-zero, any of this non-zero, x or y will always give you 1, 1, 1. And any of this has 0, 0, then x and y will give you 0. But when both are non-zero, it will give you 1. The conditional operator. Conditional operator, we also call it as a ternary operator. This is very simpler form of if else. This is simply if else. So if the expression 1 is true, expression 2 will be done. Otherwise, expression 3 will be done. Please see the question mark and this colon. This is how we use it. So this says if expression 1 is true, then the value return will be expression 2. Otherwise, expression 3 will be returned. We'll see an example. If xy, scanf %d %x. If x is greater than 5, if you enter a value which is greater than 5, 3 will be assigned to y. Otherwise, 4 will be assigned. That is similar. This line, this one line is similar to saying if x is greater than 5, y equal to 3, else y equal to 5. So these two are similar. We have one more example. You can put a condition is here also, means logical operations also here. So say you scan something, you say A between 65 and 90, you assign 1. If it is not between 65 and 90, you assign 0. There are certain points where you need to understand. It is not always necessary that the conditional operator should be only in arithmetic statement. You can also have printf or any operation which is possible in as a statement. So we have int I scanf, you are inputting some I. If I equal to 1, you print Amit, otherwise you print all and sundry. If A is Z, you can also put this ternary operator or conditional operator inside a printf. So now putting inside the printf, if A is greater than this, you assign A, so A will be printed, otherwise exclamation mark will be printed. This conditional operator can also be nested, so A greater than B, Again, you'll get a result from here, you get a result from here. So this is already nesting. This is one more problem is there. If you do or write this, you'll get a L value required. That means logical value is required. Why? You have to put this in the round brackets, because what here compiler assumes is, if you're not giving the round bracket, that means the compiler will see that this B is being assigned to the result of the expression of the left of the second is equal to, and it reports an error. So just making or putting the parenthesis will solve this issue. Let us summarize what we have seen. There are three ways of taking decision in a program. If else, we'll see. Second way is to use the conditional operator, and we have a switch statement. We'll study about this switch, etc. We have seen if else here. The default scope of if is only the next line. So if you want to execute more than one line, you have to put those lines inside your braces. The if block need always be associated with an else block? No, it is not always. But an else has to be. An else block is always associated with an if statement. If the outcome of the if-else ladder is only one of the two, answer yes or no, the ladder could be easily replaced with else if or by the logical operators. The and or, these are binary operators. This exclamation, it is not operator, it is a unary operator. These, they require at least two expressions or values. This only require one. So if in C every test expression is evaluated in terms of 0. All other values apart from 0 they are non-zero. Assignment statement used with conditional operator must be enclosed within pair of parentheses. Okay, parentheses. So this is all about this chapter, that is the decision control. Thank you so much. Take care of yourself.